Solid Edge is one of the best CAD programs to work with imported geometry, which comes from other CAD programs, and it will work with a number of programs in their native formats. So, for example, I'm going to just go through some examples and show you some of the great tools that are available. I'm going to start off with an Inventor file. This is just a part file, so if we just double click on there and go to the part template, and that will import it and convert it to what's commonly known as a dumb solid. And you'll see that we have a warning on here, just saying that the geometry could be optimized a little bit better. So we can go to the inspect command, click on optimize, and accept the whole thing, and it goes through and cleans up any sort of road geometry that it can. So most CAD programs will allow you to move face, rotate face, that sort of basic geometry manipulation. Solid Edge allows us to go much further than that with the Synchronous technology. So all we need to do is select a face, and then we can just adjust it backwards and forwards as you may want to. You'll notice it sort of dropped a lot of the geometry at some points if you go too far. Obviously, it can't recompute. Now, if we wanted to, we could hold the control key down and add in an extra face. If we want to maintain our offset between the two on here, and we can then sort of just drag that out and make the whole thing fatter. Alternatively, if I switch to my front view, I can do a fence selection on that whole area there, and then we can then just move the whole thing, and it maintains the thickness on that. You'll notice that it does extend up the rib to fill in the gap in between. Obviously, at some point it gets to where it can't recompute. So we could either delete that as a feature or modify it differently. So that's the first level, is just basic manipulation. If I come on here, it gives me a diameter on that surface. So I can then click on there and adjust it. And you'll notice with the design intent, it's adjusting the whole thickness of the part, maintaining the tangency between the side edges and the main one. So we can adjust it that way. But you'll notice that the distance between the outer and the inner surface isn't being maintained. So what we can do is we can do a face relationship. This is similar to the relationships that you use when constraining 2D geometry. We have an offset command in here, so I can click on that, select the inner hole, accept it with the right mouse click, and the outer surface, and accept that. So it's a 10 mil distance between the inner and the outer surface. So now if I click on the outer surface, hitting the escape key, you can see that we've got the diameter again, and as I adjust that, you'll see that the distance between the outer surface and the inner hole is being maintained. We can turn that off if we wish, so you can override any of these constraints, and we go back to how we were originally. So you can set up the information that you wish. Similarly, I could reposition these holes. So if I select two holes there, we can click on the torus plane, and then we could move them around however we wish. If I escaped out that, just picked one hole, you'll notice that it's got symmetry on there, and both will be maintained on that scenario. Similarly, I could put in a relationship on here. I could put a concentricity. So I could say, well, actually, I want to maintain that hole there to be concentric with that outer edge there. And it's moved both to match that, because it's got to maintain its symmetry to do that. And you'll see that both faces were highlighted in blue. And over here, you'll see that we have those two relationships being displayed in the Pathfinder. Now, if we want to edit this face here, we can click on that and drag it out. You'll notice that the rib is extending, and the reason for that, and this is the key to managing files in Synchronous, is knowing that the geometry is connected. So it's got a tangency on here, and that sort of runs into that edge of the rib, so it's going to maintain that as well. Now, if I want to try and break that, I need to clear the radii on the outside. So I can go into Selection Manager, so Shift Control, and if I pick up on a part of the round, I can go round chain, so that's going to go all the way around and pick up the connected edges. I'm going to do the other side as well. Notice that it's not picking up this front face because it's not a straight round, because you've got that break in there as well. Shift Control to, Shift Space to turn that off, and then I can delete that, and we are left with this area here, which I can then just delete manually. So from here, I've got the option now of being able to drag this out. Notice the holes are moving with it because they are maintaining that concentricity. If I hit escape, I can also modify the size or position of this rib. What I might do is just go and pick the radius on here, and I'll go with a round chain on there, and I'll just delete that as well. Gives me a clearer feature to work with. And I can then click on this top face here. If I click on the control knob of the steering wheel, I can position it, and I can adjust the angle of that rib to whatever I want. I could control that with a dimension as well. So dimensions can be used to drive geometry. So likewise, I can click the choice this way and adjust it, keeping the position at this end fixed, and I can then adjust that up as needed. So this gives you an example of how we can use face relationships and just general synchronous technology to generate changes on this. As I said, if I wanted to, I can control these with dimensions. So if we go Smart Dimension and pick up on an edge, I can specify that I want to have this as a driving dimension. Notice that the back face here is highlighted because the arrow here is highlighted. That means that that's the face that is going to get modified. I can make it symmetric by clicking on the center arrows, which means it's going to modify both directions, or I can modify this edge to be the one that's moving. But I'm just going to change this to 130. So I'm changing the width of this. The design intent is still taking into account the position of the hole. So when I hit enter, the holes move with it as well. So we've now created a parametric model based on dimensions. Likewise, I could then also put a smart dimension between this edge here and this edge here. And again, I want to lock this, and I'm just going to move the outside face on the right hand side this time, and I want to make this 70, and that extends that out. So you can see that we've got a number of different controls on here to manage this. If I wanted to, I could add some dimensions across this top edge here, so I could go from there to there, and I want to make this face here at the front the one that is moving, and I want to lock that in at 18. So now if I pick up on this dimension here, if I hover over and change this dimension, so this is the face that is going to change. If I adjust it out, sorry, what I needed to do was add a dimension on from here to here, and I'll lock that one. So now if I come to modify this, you'll see that those relationships are now driving the model as well. So you've got full control over how this imported model is behaving. So let's move on to a separate part file. So if we go to File, Open, and we're going to look at a Pro-E file this time. So BRT tells me that it's a part file. So I'm going to bring that into a part template. Like we did before, I can go into Optimize, accept that, and just make sure that it's recognized as being clean. So we've got a part here. We can do the sort of obvious ones. We can click on here and make that longer, and you'll see that it's centralized. If you're not central on the coordinate system, obviously, you know, that's your key form for driving symmetry and so on. What we could do is we could just select the whole thing and then move it so that your area is positioned around the coordinate system to give best effect. So yeah, we still do the same things we did before. We've got a diameter so that we can make that bigger or smaller, or we can pick up on an outside edge. And I'm just going to make this bigger. And obviously you see that it's picked up coplanar. So I can hit the P key and that turns that off. So I'm just going to drag this out for a distance. So now what I'm going to do, I'll show you why I did that. I'm going to do a fence selection of this region here. So basically we're just looking at this arm. I want to keep these the same orientation, so I've made this bigger. So I'm going to flare out these flanges. So I grab the central knob of the steering wheel, and I want to make sure that I am coming off of that inside edge. So I'm going to bring it in here because that's where I'm going to rotate it around. So if I hold the shift key down and click on the torus just a couple of times to get the orientation right, you'll see that what we get is the ability to add some flange in here. So I've still got that internal face, so I'll keep that as is. If I want to, I could just turn that off. I hit escape and select that face with the control key. That turns it off. need to rotate this around again. So now when I rotate, what we're doing is we're moving those out, and I want to come out, say, 20 degrees. And then from here, now that I've got a position where I want it to be, I can then sort of come in and bring those back into a size that is more applicable for this. And like I did before, I can add dimensions on here. I can dimension it from the center out to here and then the thickness. But we've done some pretty radical changes to this part without any reference to a feature tree. So now let's look at the next file that we're going to work with, and we'll go with a SAT file this time. So if I just open that using the part template, you'll see that we have our model. Optimizing isn't essential, but it just sort of gives me something to clean to work with. So we've got this part here. Maybe we decide we want something similar, but with these features rotated 90 degrees. So I can do a fence selection of all of that. If you've picked up on any edges that you don't want, you can just deselect those. But that gives me a very quick way of getting in. So clicking on an edge for the steering wheel will put it on the center point of that item, and then I can just click on the torus and I will rotate them around to avoid the key points. Click it around 90 degrees. I could just type that in as well if I wish. So we've got an easy way. We may want to change the width of this. If I click on the arrow in this direction, we've got symmetry on. I can turn that off if I want to have one side bigger than the other, but that is controllable just with the S key. I can turn that on or off. Also, we can add in a dimension, so I can dimension between the two items, and the orientation of the dimension depends on the orientation of the view. So depending on which way you want to take it, I'm going to go this way, and I'm just going to place my point here, and I want to go symmetrical, and it would do that anyway, but we want to make that say 90 this time around. So one of the things that can get a little bit tricky is just the ability to, if I click on a circumferential face, I can change the size, but we're going to run into this hole. So we might want to make sure that as we make a change on here, it will move this out to allow for it as well. So I could use my face relate on those. A little bit more difficult when you've got a rounded surface. So what I'm going to do is go into the surfacing commands, and we have something called a live section. And this live section is going to be placed on that center plane there. So basically what it's doing is it's taking a slice at that point. If I wanted to reposition it, I could use a steering wheel and come off the center of here, for example. But I am more than interested in looking at it at that point. So you can see if I hide the design body, we've still got this. So if the model updates, the live section will update. If I modify the live section, the model will update as well. So let's go in. I want to keep the distance sort of set around this cutout here, but I'm going to need to make the rest of it locked down. So if I go to Smart Dimension and I will start adding in some dimensions on here. I'm going to lock this one down and place the next one. Now I want these to be lock dimensions because I don't want these values changing. And then finally, I want the distance from this face to the vertical face here kept constant as well. So I'll place that on and go back and show my design body. So from here, what I can do, I'm going to create a offset between the internal and external edges. That's currently set at 9.3. I'm just going to accept that. So we have our relationship in here. So now if I click on this face here, I can then scroll out and we maintain the distance between the edge and the cutout, and the distance between here is maintained as well. So we can then sort of set it to a value that is critical to the way that we work. So the next one to look at is a SolidWorks part. So we're just going to open this up. Now this one here is something we can work with. Like with the other options, if I click on here, you'll notice that it will pick up off the tangential faces, so it's recognized that it's all connected. I've got symmetry turned off at the moment. If I turn that on, it's not making any difference whatsoever. So if I hit escape and we look at the view here, you'll see that we have the whole thing drawn off center. So all we need to do to fix that up is to do a fence selection. If I go back to that view there, you can see that we're sort of off center. So if I position my steering wheel on the midpoint here and then drag it across in that direction, I can click up on that coordinate system, and then that makes it all symmetric. So now if I pick up off one of these faces here and adjust that through, you now see that it's automatically picked up on symmetry, which we could obviously turn off if we wanted. Likewise, I can use my selection manager. I pick up on this face here and go recognize feature again. It's picking up not only the cutout but the rounds on it. I can turn off the selection manager and hit delete, and it does a repair on there. So now we've got the same sort of tools that we've used in the other parts. We can do a modify here, so that does symmetry in two directions. Likewise, I can also select that face there, and you'll see that it now gives me that. Or alternatively, I can then go come back into this profile here. I can do a fence selection and do a modify, keeping that slot the same gap to the edge across here. Similarly, we can place a dimension across here, and as we've done before, if I make it symmetric and start scrolling, we have the same sort of thing happening. It's maintaining the symmetry. Now I can also control, if I do a fed selection across here, I can still control the whole thing using my dimension just by selecting that face. So we have total control over the part that we have brought in here. So moving on to another file type, we're going to go down into a step file. And this one's a locking plate, all the usual applies. We've got a hole counter drilled in here. We have the option of recognizing holes. So we've got several in here. We've got hole 1, which is a simple hole, 35 diameter. We've got one this side, which is 40. One on the other side is strangely 39.69, and then we have the big hole in the middle. So let's just change this one here, and rather than being simple, we want it to be flat bottomed, and we want the diameter. We don't have the options here because it's not a standard size, but I will make this a 40, and you'll see that it's updated in here, so we can go accept, and then we have the options here so that we can then go back, and if we want to, we can edit any one of these using the normal method. So this has now become a feature within the Synchronous model. I go into hole options. I could change its size once again, and I can go and change it to through next, and then you'll see that that comes through. It's coming right through to the central thing because it's down below the surface. So to get through to clear space, it's got to cut out here, and I could do that to the same to the opposite side as well. If I want to change, have it controlled by dimensions, I can add dimensions. And it doesn't matter which way the arrow is pointing because it is symmetric. So even though it's pointing in one direction, it's just going to, sorry, that again, that one to that one. And again, make this 200. So we've now brought in a part and modified it and constrained it to new size. So it allows you a lot of flexibility in how we modify these parts that we're bringing in, which effectively are dumb solids. So the final one I will look at here is a SolidWorks assembly, and SLDASM. So obviously I'm going to open that into a solid edge assembly template, and you'll see that we have this scenario here. Typically you'll end up with grounded parts. It's just taken the position within the assembly of the part as it was last positioned. So we've got the screw, we've got the base, so the component and the base as well. So imagine that we want to sort of adjust this so that we've got a bigger gap between the two. What we can do, let's start by using the relationship manager. So we're going to ask it to check everything in select set 1 against all other parts. So my select set 1 is going to be everything, and rewrite mass clip to accept that. You set your options on what it wants to find. So we want a planar axial align and a mate, and then we go process, and that comes back with a list of relationships that it's going to apply. So you can see it's used reference planes as well as faces and so on. So once you've done that, you can go accept, close and finish. So now when I pick up on a part, you'll see that it now has relationships other than just being grounded. So as I said, I want to sort of move this out. You can see the icon on the cursor is yellow, which means it's part, so it's selecting individual parts. Because these have all been brought in, imported, they are all synchronous components, so I can now modify the assembly in its entirety. So I'm going to hide that part for the moment. Just look at the side view, and if I go Control Shift, see the cursor's gone to a whitish color, so I can do a fence select on faces in the assembly now, and I can increase the size of this by say 5 mil, and that's modified both this part and this part. Let's go back to base, and because we applied our relationships, the mates on here have still held together, so I've been able to modify the assembly. If I wanted to, I could go back to base priority. I could then say select just that top portion there. I can reposition my steering wheel based on the center of the bend radius, and if I wanted to, I could change the get my positioning right. I can change the angle on this, say down another 5 degrees. So you can see that we don't actually have to go into the part to make edits. And yeah, this is all very powerful stuff. And if you are working with foreign geometry, it's invaluable on how you can make these modifications. It allows you to bring in standard parts that are out there on the internet and customize them to your own designs. But it also gives you a lot of flexibility when you are designing from scratch, because you can then just move, push, pull the design to get where you want to, because you don't always know where that's going to be. I hope you found this informative, and if you've got any questions, then just drop me a line in the comments.